Hello, my name is Martin Schweinberger and I am presenting a paper entitled Text Mining the COVID-19 Discourse in the Australian Twitter Sphere that is a result of a collaboration between Michael Haugh and myself from UQ, as well as Sam Haines from the Digital Observatory at QUT. The slides are available on my website and the ARC code is available upon request once the paper has been accepted for publication. When you think about why someone should analyze COVID-19 discourse on Twitter, there are two main aspects to it. First is, well, it's an interesting topic and so it's worthwhile analyzing. And the second is, text mining approaches that have been applied to COVID-19 discourse on Twitter have predominantly treated the discourse as one monolithic block rather than realizing that it consists out of several sub-discourses. Also, such analyses do not differentiate between different phases in the development of that discourse. In addition, previous research is predominantly done by non-linguists, which means that they are unaware of what linguists have learned about how to analyze discourse. This can be seen in the fact that COVID-19 discourse is treated typically as an undifferentiated bag of words, and the focus is placed on individual hashtags rather than the language or the discourse itself. Alternatively, when the analysis do not take a text mining approach, the analysis are based on small or unclaimed datasets of either only official channels or the analysis focuses on very small time spans or very few days. This presentation will continue with a brief introduction to this research. Then we'll have a look at the data that we've used in this study and we'll talk about how we analyzed it. The analysis section will also summarize and highlight our main findings. Finally, the presentation will provide a conclusion of the study and provide an outlook on what we've planned to improve this project and what can be done in the future. The starting point for our study is to question if the COVID-19 discourse went through different phases and how these phases differ from each other. In this respect, we were wondering if and how corpus linguistic methods such as cross-tabulation or keyword extraction can help in identifying patterns that broader machine learning approaches fail to detect. We specifically hypothesized that the COVID-19 discourse went through three distinct phases, where the first phase focused on COVID abroad, in China specifically, a second phase that was dominated by discourse around the lockdown and COVID in Australia, and a third phase that focused on the economic consequences and repercussions of COVID. We'll now look at the data that we used in this analysis. The basis of this study is data from Twitter, as you can see here. While there are various pieces of information available when analyzing Twitter data, for this example, we only considered the text of a tweet and the date when it was published. We collaborate with the Digital Observatory at QUT, which collects Twitter data via official Twitter APIs. Specifically, we asked the Digital Observatory to collaborate because they have identified 500,000 accounts as Australian, of which approximately 100,000 are active Twitter users. This collection, which is called the Australian Twitter Sphere, has been collected since May 2018 and it amounts to 25 million tweets per month. The data used in the present study represents a 1% sample of the Australian Twitter sphere from two time periods. The first time period was January 1st to April 20th, 2019, and the second period was January 1st to April 20th, 2020. We used data from 2019 as a control corpus, where we trained the classifier, which was used to identify COVID-19 tweets. In terms of data processing, the entire workflow, that means the processing, analysis, and visualization, was done in R so that the entire analysis is replicable and reproducible. In the first step, the data was cleaned by removing non-English tweets and so-called stop words that do not have any semantic content. In addition, we converted everything to lowercase. At this stage of the project, we did not lemmatize the data and we did not correct any spelling errors. The cleaned dataset consisted of roughly 1.7 million tweets or 35 million words. Within this data, we identified 41,342 COVID-related tweets, which consist out of 1.3 million words. To detect COVID-related tweets, we used a support vector machine-based classifier, which we trained on 5,000 tweets, 750 COVID-related tweets, and 4,250 non-COVID-related tweets. The classifier performed extremely well when tested on 1,250 tweets that the classifier was not trained on. The advantage of using a classifier over, for example, hashtags is that a tweet may be COVID related, but it might not have a hashtag that's related to COVID. So we actually get more of the tweets than if we would just take hashtags as a basis. Here you see the percentage and frequency of COVID tweets in the 2020 data. You can see that there is an initial spike when the news about COVID broke in China, and a second, much more substantial spike when COVID reached Australia and spread across Australia. We extracted COVID-19 related keywords by extracting words that occurred significantly more frequently in COVID tweets than in non-COVID tweets. We also had to apply Benjamini-Hochberg corrections because we ran thousands and thousands of tests to detect such COVID-19 related keywords. Here you can see a heat map with the frequencies of the COVID-19 related keywords across time. The dark shade shows that the COVID discourse is like a wave that peaked in late March, early April in our data. Here you can see the percent of tweets in which selected keywords occurred. And you can see, for example, in the upper left panel, that China peaked in late January when the news about COVID-19 in China broke. You can also see in the center and right upper panel that the term coronavirus, which was the initial term of choice, was replaced by COVID-19 in early March. To identify different phases in the COVID-19 discourse, we applied PAM clustering with 1 to 20 solutions to the per-day keyword frequencies. Using optimality scores, we determined that the data consisted of 7 main periods, as you can see in this dendrogram. The first phase is the longest, as it lasted from January 1st to February 24th. As can be seen in this plot as well. Also, it is interesting to see that the periodization corresponds with increases and decreases in the overall frequency of COVID tweets. After having determined these phases, we use cross-tabulation again to identify keywords that are characteristic of each of the phases. The advantage is that this way we'll not only get keywords that are particularly frequent in a phase, but also words that are significantly underused in a phase. This plot shows significantly over and underused words for each period. Interestingly, COVID-19 was underused in phase 1, because back then the term of choice was still coronavirus. You also see some other patterns and distributions which I cannot go into for time reasons. We then performed LDA-based topic modeling on the data to find sub-discourses within the COVID-19 discourse. The topic modeling converged on 5 thematically coherent topics. Topic 1 deals with medical issues. Topic 2 focuses on COVID abroad and issues related to international travel. Topic 3 deals with the restrictions and home life. Topic 4 focuses on the spread and causes of the spread in Australia. And topic 5 deals with the economic repercussions of COVID-19 on Australia. This plot shows how the topics changed in importance across periods, with again the first phase being dominated by the international theme, as shown by the extended bar for topic 2 in the left panel. We also see in the right panel that issues relating to restrictions and home life gained importance over time, with a peak in early to mid-April. This can be seen by the upward trend in the dotted line and the dip during phase 7. Finally, we performed a sentiment analysis to see how the emotional response that is encoded in the discourse changed over time. The sentiment analysis is based on the word emotion association lexicon, which is a crowdsourced lexicon of about 10,000 words. The sentiment analysis shows that the international discourse was overall rather consistently negative, whereas, for example, topic 5, economy, topic 3, restrictions home, and topic 1, medical, dipped during phases 2 and 3, and quite notably so. This is when COVID initially spread across Australia, but then soon recovered and were increasingly positive. We now turn to the conclusion and outlook. The analysis has shown how machine learning, so classification, topic modeling, and sentiment analysis, can be enhanced with corpus linguistic methods, such as keyword extraction and cross-tabulation. Using machine learning-based approaches only would provide us with a rather superficial view of the COVID-19 discourse. On the other hand, using only corpus linguistic methods in isolation would provide us with detailed insights, but they would be limited to certain aspects of the discourse, because you could only analyze limited amounts of data of few users. Breaking the discourse down into phases and sub-discourses, as we as linguists frequently do, and combining machine learning and corpus linguistics can help us in providing a more detailed understanding of the discourse around social phenomena, in this case COVID-19, and it allows us to unearth patterns that would not be detectable otherwise. Moving forward, we want to use the entire dataset rather than the 1% sample that we used in this study. And obviously, we'd like to extend the time limit to encompass the entire year of 2020 rather than only the first few months. Also, we want to combine the approach presented here, which focuses on individual words, and expand it to anagrams. This means that we can move away from only individual words to combination of words and phrases. We then want to apply this prototype to other social movements and phenomena, such as Black Lives Matter and the bushfires, to better understand the discourse around these phenomena. Also, it should be noted that because the prototype that we've created is replicable and the code is available to us, we can apply this now more easily to new phenomena. We need to really acknowledge the work that the Digital Observatory has done, because the Digital Observatory has provided us with the data that we used in this study. They were very friendly, and if you want to use Twitter data in your analysis, I can only recommend that you contact them. They are really helpful and they've done a great job. Here are the references that we used in our analysis, and we'd like to thank you very much for listening. If you have any questions or suggestions, please feel free to contact us, and we are happy to get back to you. Thanks.